Hi, Samuel. Good morning. Good morning, Samuel. Can you hear me? Let's wait for the speaker. The speaker will join us in a minute. Let's give us a few seconds. Good morning, everyone. The session will start shortly. Let's wait for. We're waiting for the general room. Once the general room is done, we'll do. would keep that. Everyone, we're trying to wait for our speaker. It's coming. morning, guys. Sorry, we are about starting soon. Once the general room is over, we will kick off this session. Thank you so much. Once again, thank you so much for joining this room. My name is Adekoya Teleora. Once the general room is over, we'll start this session. Thank you so much for your time. Hi, good morning, everyone. Thank you so much for your time. Thank you for joining this call. Thank you for your response. We have our speaker here in the room. His name is Oluwaferanmi Babayemi. Oluwaferanmi happens to be a renowned data scientist, whereby he is going to speak on the specialist on AI in Nigerian industry. Ferami has played multiple roles in the various vital roles in the agricultural sectors, and he enjoyed popularity and made significant contribution to his economy. As you join me, make a joyful round of applause as we welcome Ferami on stage. Thank you. Over to you, Ferami. Good morning. Ferami, are you there? Good morning.
Hi, can anyone hear me?
I can hear you, Ferami. Good
Oh,
morning.
okay. I needed to be sure. Okay, it's great to be here again, right? And let me just know when my screen is up, when you can see my screen.
Yeah, I can.
Okay, so welcome to everyone. And good morning from Nigeria, and good afternoon, good evening, anywhere you are in the world. So um, the focus this year is on geospatial artificial intelligence because there has been some quite interesting development around that place, especially for me personally because it's been one of my major study for the year, and I thought this would be a great platform to share one of the little things I've actually learned with my geospatial colleagues, right? But because of time, right, we might not be able to go so deep into into geospatial AI and its integration with the Nigerian agriculture, right? Because I think we have barely 20 to 25 minutes there about. But I would try to place you on a path, especially if you're a newbie, place you on a path where you can now learn yourself, right? You can be able to at least whatever you hear here, you can be able to build on it. It's meant to be a foundation for you to actually build on, not something so big, but I mean whatever you hear here will be able to help. So geospatial AI in Nigerian agriculture, how it integrates with AI, how it integrates with farming, and how it integrates with agriculture as a whole. My name is Oluwaferanmi Babayemi, right? You can find me on Twitter as Fermi Babs, where I tweet majorly about geospatial things, right? I I'm a geospatial data scientist, right? I'm tending towards focusing on machine learning to solve geospatial problems, right? And I think it's important to actually say that everything I say represents my personal opinion and what I see concerning geospatial AI. It's not that of my where I work, or it's not affiliated to where I work. I hold my BSc and masters, right, from FUTA. I studied remote sensing and geoscience information systems, right. So yeah, I think that's an eye level overview of who is probably talking to you. And as the picture says, I think this is how I look. So yeah, a run through of the agenda says that we would first understand what geospatial AI means. I understand, yeah, Grace Materia, thanks, man. I understand that many of us here will understand what geospatial means, what GIS means, geographic information system. What I'm imagining that you understand what remote sensing means, but at what point do we integrate geospatial and artificial intelligence? And that's one of the things we'll be learning. The second point is, since we're talking about the integration of artificial intelligence, right, with the Nigerian agricultural landscape, right, it's also quite important to understand the challenges, right? The reason why the challenges are the reason why we are even considering this in the first instance, right? The major reason, because if there are no challenges, there is no need to solve any problem, right? Problem necessitates solutions. And if we're saying geospatial AI is a solution to the Nigerian agricultural landscape, then we have to mention how the challenges, right, ravaging that part of the sector, that sector, right? The third one is understanding the integration now, where the geospatial data comes in, then where does the AI technique for agriculture comes in, then we should make some discourse around precision agriculture and climate adaptation. It's everything about agriculture is around climate, right? Then we look at one or two case studies, look at where a possibility of the direction of where geospatial AI and agriculture is going, then hopefully we have time to give room for question and answer session, right? So yeah, what's geospatial AI? So geospatial data, if I don't know if there's anyone here that was in my session last year where I was talking about transforming the logistics industry and transportation industry. And I was trying to explain in a pictorial way, right, what geospatial, okay, thank you. If you remember, I was trying to explain what geospatial meant. And I was trying to explain how that if you're in a maze, if you're picturing yourself in a maze, right, where you're currently standing as what is called longitude and latitude, right? The other side of the maze also have a position. So every point on the Earth's surface possesses a position that is called coordinate, right? And they are called latitude and longitude. So for everywhere you are, the ability to be able to know where you are, or the know-how to be able to track where you are in quantitative terms, right? The quantitative terms is what is the latitude, what is the longitude, then it means that you are using geospatial data, right? Everybody uses geospatial data. If you are lost or you're going somewhere, you pull out your phone, you're trying to use Google to navigate your way, you're actually working with geospatial data, right? So that's geospatial data in itself, data associating to place, associating to location that can be depicted using latitude and longitude. Then the other one is AI integration, right? How artificial intelligence techniques such as ML, computer vision, deep learning, predictive analytics, how all of these intertwine with geospatial data to actually extract patterns. You know, majorly when you're building when you're building a machine learning model, when you're working with computer vision, what you really want, predictive analytics, deep learning, is to recognize patterns across different spectrums in whatever area of life, agriculture, finance, football, anything, right? You're looking for patterns, you're looking for trends, you're looking for actionable insights that can be able to tell you something about tomorrow, that can be able to tell you something. So when you're integrating geospatial data and AI integration, you're simply saying that you want to be able to know something about the Earth's surface, you want to be able to know something happening on the Earth, specific places, and you want to be able to talk about, say, what can happen tomorrow, right? So that's where geospatial data and AI actually meet. Now, having understood that foundation, right? We need to now understand the challenges that the Nigerian agricultural landscape possesses, right? And to be very honest, right, unlike when we were discussing transportation last year, we really have a genuine problem with transportation in Nigeria that is kind of different, right? Of course, contributed to by the population, contributed to by the road networks, contributed to by maybe the fact that the government haven't done so much also to combine our road networks very, very clean and neat. Some of so that those ones are specifically peculiar to the Nigerian context. But in this case, concerning agriculture, there are certain things that are just global, right? And you just have to live with them. It's not that you expect somebody to bring money to solve your climate problems or weather problems. No. So the first problem is actually a global problem, which is climate variability, right? There is there is actually this thing that climate can do, and it is called unpredictability. The days you expect rain to fall, or the periods you expect rain to fall, you just see that everywhere is dry. The days you don't expect rain, you see everywhere is flooded. And it has the capacity to do that due to a lot of processes with the ozone atmosphere and all of that. So that's the first challenge, right? A first challenge, but also one that is worthy of note, to say a global challenge, a global challenge. Now, the other one, which I think that we can now start to fix ourselves, is the smallholder farms, right? If you eventually, there are a number of papers. Because I was a research student, master student. I tend to read a lot of research papers, right? And if you read agriculture research papers, papers speaking about agriculture, GIS, and all of that, you tend to see that the statistics, the bulk of farmers in Nigeria actually work with small farms, right? It's just many people, just the ones at the back of their house. Some people just have something where they can at least get something to feed. They just plant some number of yams, some number of corns, and all of that. The people who do it on a very large scale are very minimal, very, very minimal, and which is also one of the challenges we have. And you could paint that, you could trace that to the economy, you could trace that to how the country is at the moment, and even to other things that are easily solvable, right? So that's the other one. And the other, it's called smallholder farms, where they operate on small plots of land. In fact, many of you here probably have where you're growing corn. I mean, our president said we should grow corn, right? So so you, at the back of your house, which is probably for you to just feed, or for you to just, yeah, or for you to just sell and get something at the end of the month. Then the third one is resources management issues. One of the very, very important aspects that AI can come in to really help us in the agricultural landscape is this resource allocation, right? As we go on in the learnings, we'll come to understand how we can efficiently, how that AI can help us to efficiently allocate water, efficiently allocate fertilizers across different plots, which is, to be very honest, quite fascinating, right? And also the availability of real-time data. I mean, that works wonder if there can be real-time data availability, right? You're looking at your crop, and you're seeing how they've been growing in real time, like we call something yield prediction models, right? How they'll be yielding with time. And then because of the current data you have, even without running any models, to be very honest, you can be able to say that in 2 weeks, in 3 weeks, I should expect this level of harvest, right? That really changes things on a very wide scale. Then the last one is the data gaps. Of course, it's a Nigerian problem. I, for one, I'm always shouting about data. Being at NASDAQ to say, I mean, we need data. I was about finishing my project when I was about rounding up. And I even held a space to say, where can we even find data in this country? Like real data, not some doctored data. So it's a problem. It's a real problem. Farmers often rely on traditional knowledge. Of course, they lack access to modern data. I think one that is not here is actually that a lot of our farmers are actually uneducated. Yeah, I think that's also a big problem. So if you're uneducated, how do you want to use real-time data? If you're uneducated, how do you even know that data is even useful for you? So these are some of the challenges. Now, let's look at the intel. What is the role of geospatial data in agriculture, right? I already explained what geospatial data means, but how do we even like get this geospatial data, right? You could discuss about geospatial data top to bottom. You could say everything around it, but it's useless um when you can't even use the data. It's useless when you don't have the data, right? Because everything you do with machine learning, deep learning, computer vision, they are heavily reliant on data. you don't have data, you don't have any model. You don't have any model, you can't predict anything. You can't predict anything, you better make do with what you have now. So it actually builds on each other, and it starts by having access to data. So the first kind of data is satellite data. So for the newbies here, probably you're just getting introduced to geospatial or GIS or something like that. What we call satellite data is this. Okay, so of course, when you look up, what you see is sky, right? That blue layer that never seems to end. That's what you see. But a bit altitude higher than that, right? You have something that has been installed there that are called satellites, right? What is the function of satellites, right? You're trying to picture something up there that has the capacity to snap you where you're sitting now, right? Of course, it can't get to you because you have a room over your head, but it has the ability to actually snap that room over your head. And then because it is snapping that room over your head, it attaches coordinates, the longitude and latitude. So I can actually know where you are. If you get that picture, you can actually see where you are. You can actually see other places that are near you. And so what satellite data does is it gives us a wide overview of the Earth's surface, right? Depending on the kind of satellite data, there are different kinds of satellite data, Landsat, Spot, and all of that. Depending on the kind of satellite data, you can do different analysis. So let's say, for example, I'm a farmer. I have some 10 acres of land, or 10 acres of where I'm growing corn. Sorry, corn seems symbolic. So and then you have a satellite data for it. You can come through those satellite data to see specific places that are very green, places that are going yellow, just because you have a picture, rather than walking through the length and breadth of what you have. But the problem with satellite data is that because it is very, very far from us, the pictures are not that clear. It's not your iPhone picture, your Samsung picture, right? So the second kind of data that we have that we can make use of is called drone data. And drone, everybody knows drone, right? That thing that just flies over, just not so high, right? And not so far, right? It just flies over, and then as it is flying over, it is actually capturing. It is capturing the places that it is flying over, right? And the advantage of that is that it is very close to you. So it gives you very clear pictures, very clear pictures. And of course, that when I say very clear pictures, that's referring to high resolution, right? And then the problem with that would now be that it is very costly. It is quite costly because it gives you very high quality, but then you'd have to pay good money to get it. The last one is GPS data. GPS data just records your location. So one of the things that, so for example, if you lost your phone now and you're trying to track it, what helps you track it is that GPS data. It's embedded in most phones these days. So it just, once it can track your longitude and latitude, it automatically derives your location, right? So it's in Ikeja, it's in US, it's in San Francisco, and all of that. So those are the three types of data that we really need in agriculture, and we'll see their usefulness as we go on. Then the other types, we make use of maps, right? And maps are very, very important. So what this data does is that it makes the data available. What map does, maps make the data visual. And that's why I appreciate maps so much, because what you have on your phone when you pull up your map, when you pull up your Google map, are the satellite data. That's what you have. But maps essentially helps you make sense of that satellite data. And that's how everything becomes sensible to an average human being, right? I mean, whatever you say about satellite data, many people do not care, but let me be able to use it. And land use maps. So what land use maps does is land use maps, and it's something I do very well. Land use maps categorizes the usage of the land, right? There are certain specific there are specific areas of land that are used for residential buildings, right? There are specific areas of land that are called bare lands. Bare lands means you could classify desert into those classification to say that nothing is growing on it. It is just bare and all of that. So it classifies it vegetation, water bodies, and all of that. So by the time you're looking at a land use map, you say, oh, this place is near the water. It's a good place to actually have your farm. This place is near residential buildings. Won't they destroy my farm? This place is near the forest. Things like that helps you make good decisions. The second one is soil quality maps. So this contains information such as moisture content, right? How good is the land for farming, pH levels, and all of that. Then topographic maps, it provides the elevation data. I think I need to move fast now. Provides elevation data too. And the reason why you need your elevation data, also known as DEM, digital elevation map, is to understand the level of flow of water and how your irrigation systems will actually be structured when eventually you are using that place for farming. Because of course, water flows in the direction of steepness, right? The more steep it is, the more water can actually flow down, right? And you have to consider that when you're actually picking a farmland or where you want to water your farmland using irrigation systems and all of that. Yeah, so data collection methods are now remote sensing via satellites, drones, and then you now transform them into maps that make sense to the average human being. So now let's go to the crux of today. The reason why you probably joined here, the key AI techniques for agriculture. We have different AI techniques, and I've been mentioning them since morning, right? And you have machine learning, you have deep learning, you have computer vision, and all of that. But let me spend some time here because this is what I do. This is what I love, machine learning, right? Now there are different models. I can't just, I don't have 1 hour, I don't have 2 hours to speak to you. So I just have to mention these 3 models. But there are lots of models, right? But yield prediction models, what does yield prediction models actually mean? And to be honest, because it's very high level, I don't want to go into types of models to use to build specific kinds of models here and say, okay, data random forest is good for this one. No, it is just, again, it is just an overview, a foundation for you to actually step on if you're interested in something like this. It predicts crop yields. Now, there is something that happens every time you plant. And every time you plant, one of the things you want to do as a knowledgeable farmer is that you want to track how your crop is actually how your crop is growing, the period, the factors contributing to it, and all of that. You want to really track that, right? And so one of the things that can help you track that is called yield prediction models. Now, yield prediction model is different from yield in itself, right? Because there are certain things agriculturally that you do to enable your yield become faster, become better. I'm not an agriculturist, right? But I know that there are specific things, but this is not that. What yield prediction model does is based on, okay, let's say you planted corn again last year, right? You're looking at how did it grow? When did I plant it? What were the factors? How many times did rain fall? When you're building a model, your model can never outperform the quality of your data. So you need quite a lot of data: your rainfall, soil moisture, the pH level of the soil, the rate of sunlight. Then you need all of these parameters. So when you're getting those historical data, you're using it to predict, okay, if I decide to plant corn again this year, I should be able to, if I have so amount of factors and they are giving me this kind of values, then I should be able to expect a better yield than last year. And this is called precision agriculture. I have people who do things like this. I don't farm, but I have people who do things like this, and it's absolutely insane the kind of results you can get. Because even if things will catch you by surprise, it is to learn, it is for your model to actually learn and give you a better result in the future. That said, remember we said that there is a global problem, which says to say that anything can happen. Rain can fall on the day it's not meant to fall. These things can happen. But the model already increases your probability of getting better yields and good yields because you're working with data in mind. And that's why data is very, very important. Data is the crux of everything we are talking about. geospatial data, rainfall data, soil data, moisture data, digital elevation data, whatever kinds of factors that will contribute to the yield of that crop, you need it to actually build your yield prediction model. The second one is pest and disease prediction. Well, maybe this one will not be model as that, but what you want to know concerning pest and disease prediction, especially pest prediction, is actually that you want to be able to detect early if pests are attacking your crops, right? And then how do you do that, right? Of course, there are symptoms, right, that every crop would have when their stress levels are getting high. There are symptoms every crop has when probably they are getting attacked by this pest and by these diseases. What you want to do, or what you want to achieve in using machine learning, is that you want to understand this stress. You want to be able to get them early on, and then you want to be able to counter it early on. That's what happens, right? That's what you want to get, right? And there are different ways to actually do this. Either look at the time of the year, either look at the factors contributing to that, either look at the reasons why, studying the pest in itself, the reason why they come, and then using it as part of your models, right? Then optimization of your models, right? Now, every other thing you build using machine learning models and all of that, they will fall into things like this, helping you to predict something, helping you to get something early, helping you to know this, helping you to know that. One of the things that you consistently have to do, that every machine learning engineer knows, is that you have to consistently refine your models based on current situations and current happenings, right? Your models cannot outperform how good your data is. So you continually optimize your model and all of that, right? And when you continually optimize your models, what it does for you, it inadvertently leads to efficient allocation of resources. That's what it does. That's what it does, to be very honest. And like that, you are managing resources, efficiently allocating resources, and all of that. Now, I spend so much time on machine learning because machine learning is what I do, but I will try to breeze over the next few slides, and then to allow for question and answer, because I think that my time is almost up. Then drones and computer vision. Computer vision deals with visual data, right? And so how you train computer vision is through how you train computer vision is through visual data, right? It's through visual data. And then you train it so much with a lot. It requires so much visual data, right? You train it with a lot of visual data, and then when it sees something that looks like that, then it can be able to say, oh, okay, this is what this looks like. This looks like this crop is stressed. This looks like this is this particular plant. This looks like this is this particular crop, and all of that. So that's what computer vision does. And to be very honest, these are the things that it could be stressful when you're training your model, but when you're done training it, it eases your work on the farmland, right? It eases it. So that can be done with crop health monitoring and plant classification. Then deep learning is one of those things that mimics your brain. If you've read about it, it mimics your brain, neural pathways, and all of that. It works in recognizing complex data patterns, right? And this also can just be likened to a step higher in machine learning, right? Where it helps you increase your yield forecast. It helps you predict long-term climates and impact. Really, that's what deep learning really does for you. Just an enhanced version of ML. Then predictive analytics, which is what we really want. Let me know what will happen tomorrow. Let me know if this thing would actually yield tomorrow, right? It's also a combination of historical data and real-time data, right? You have historical data of how this has performed over the years, and then this is the current data of how it is performing now. Let's see how it's going to perform in 2-3 years from now, based on the different kinds of factors. The factors are very important, very, very important, based on the kind of factors that contribute to it. Now, moving over now to the climatic aspect of this, how AI integrates with climate and how it integrates with agriculture. I will soon be finishing. And so if you have any questions, you can just let me know about it. So precision agriculture is the essence of what we've been discussing, right? When agriculture meets data, right? When you make decisions based on data. Now, it's an approach that uses data and tech to actually tailor agricultural practices. So you're not just doing anything cluelessly. These things, I don't know. It looks very basic, but it is very, very, very important. Very important. Whatever you measure, right, you can be able to assess. If you measure it, you can assess it. If you assess it, you can detect the loopholes. You can understand where the problem is coming from. If you know and understand where the problem is coming from, your solution comes in handy. It comes in handy. And that's why data is very important. Very, very important. So there are three major components that I love to share this morning. And the first one is variable rate technology. This one, when I when I fun fact, when I came across this variable rate technology, it was one of the research I was doing for a particular farm. And I didn't know that it was possible that you there are specific areas where you give more water to, more fertilizer to, and specific soil you put more seeds into. But that's what variable rate technology actually teaches. And when I discovered it, I tried to sit myself down to understand how it eventually works, right? But for the sake of time, I could discuss it somewhere else later on. But for the sake of time, what VRT really does is based on the data it has, based on the data it has swallowed, right? And it is using to make decisions. You can say that this particular place, let's put more seeds here because this soil moisture, the pH condition are very, very good, and then we'll get good yield from this place. This particular place needs much more fertilizer, and then it's based on its rate. Based on its rate, it gives appropriate resources to every part of the land, right? And so that now ensures a uniform growth of each of the seeds or each of the plants that has been planted. The second one is soil sensor. There is this thing we did when I was still in undergraduate. I think they call it multispectral imaging or something like that, where you carry that particular where you carry a particular, what do they call it? I think they call it imaging spectrometer. It's been a while. I was 200 level. It's imaging spectrometer to farm, and then you can be able to take the spectral classification of that crop. You can be able to talk about if the crop is stressed. You can be able to talk about the health of the crop. You can be able to talk about the surface the surface structure of the crop. You can be able to talk about its surface area. You can be able to talk about the growth. You can be able to talk about different things. Now, imagine if that kind of thing is done real time, and then you have access to data like that, right? It helps so much to make decisions even before stepping your foot out of your room about what you're going to do with your plant. You don't have to see how they are doing. You know how they are doing. You don't have to first look at them to see how this thing is getting yellow, is getting green, and all of that. And then the last one is automated machinery. Drones and other automated tools work in tandem with AI systems. I think we really underrate how good machines can help us speed up our work. Like I wonder a GPS enabled machine, like a GPS enabled tractor. I think it's in one of the case studies we just check. It is automated. You know where it is at specific time because you are seeing the longitude and the latitude, right? So the climate adaptation really predicting climate impact and building resilience. I think that when you predict, you want to be able to solve the problems that comes with what you're predicting, right? When you predict, you forecast long-term weather patterns, even though that's actually it's very complex. Yeah, you forecast long-term weather patterns. I was in a project that we're doing a flood forecast. I hope the paper will be out soon, forecasting the rate of flooding, how flooding is going to occur, when it is going to occur, how it is going to occur, the factors that contribute to it. So you forecast things like that. Then when you do that, you want to build resilience, right? Okay, food. How do I secure my crop? How do I make sure that harsh climate do not deal with me too much? Then we go to case studies.
Um,
Um,
your time is up actually, so
I
that
thought
people can ask
I've had more
questions.
minutes. I thought, okay, I'll just round up in 2 minutes. I just want to touch on these case studies.
All right.
And yeah, thank you. And then I'll give into questions. So the first case study is Magic Tractor, where I was talking about, where I said, okay, a Nigerian startup uses GPS and AI to connect small farmers together. You know what we call smallholder farmers when we're starting, such that the tractor can be tracked by the startup using their GPS. So they know how much it has worked, and then you paper the location you cover, right? Which makes enough sense, meaning because the rate of renting tractor is very, very high. So when you just track it with GPS, you know how much you've used. You don't have to do per hour, you don't have to do per this, you just do per the area. So if you can only do some square kilometers in a day, you're very good like that. So GPS helps you, and then this enhances productivity so much, so much, and then everybody is actually getting fair and real value for whatever they are doing, because it's quite costly to buy a tractor personally. Then the next one is AI powered pest monitoring, right? You use drones and AI to actually monitor your crop health. You detect pests early, and then you apply targeted treatments. And to be very honest, I think this can actually go a very long way, especially for our farmers in northern Nigeria. So future trends, Internet of Things, increased automation, and I think collaboration and investment with government will really, really go a long way in enhancing in enhancing the Nigerian agricultural landscape. So these are my parting words. Adopt AI-driven technologies. By adopting it, Nigeria's agricultural sector can actually ensure better yields. You reduce the waste, and then you build resilience. Thank you very much. So I think I can take questions now. Hi. Hello, Teliola.
Thank you so much, Fermi. That was an amazing presentation. I really learned a lot regarding prediction and also, please, if you have any question for Fermi, you can kindly indicate on the chat box, or you can use the raising up icon for that. Anyone with a question regarding data analyst and specialist?
Hello.
Hello, I can hear you.
Yeah, good morning. Hi,
Morning.
my name is Michael Shugola. So thank you very much for the wonderful section. So I think the section would have been okay if we have an end-to-end, maybe use cases. You understand? Maybe I don't know, maybe after this the data first program, maybe you can just let us see the end-to-end, like how you've been able to use this data for agriculture to solve agricultural problem. So I think that for me would be at least it would be a good one for me. Thank you.
Okay, I would love to have had that, but I had 30 minutes. If I have an end, if I have an end to end. Okay, some database. Okay, I'm coming. Let me answer. If I present an end to end data or end to end way of solving one of the problems I've solved, we just go through it in the whole 30 minutes, right? But yeah, I think I can decide to write a thread on that on my Twitter page, so you can decide to follow me. So yeah,
Yeah,
that would
Fermi, thank you so much. You can also give, like, because all participants, they will have access to the link and the all these sessions. So you can also submit that to us
okay.
regarding that.
Yeah,
Yeah,
I think I submitted already. Submitted
all
already.
right, no problem.
There is another question in the chat actually. Can I specify some database to find data? So, to be very honest, I already mentioned that there are problems concerning data in Nigeria, but I think where you can find some basic data is, I think grid3.org. I think grid3.org. I hope I'm correct. I think you can go to, there is this, I use Google Earth. So because I use Google Earth Engine most of the time, I just get almost all my data from Google Earth Engine. I'm trying to type them in the chat. .org, please, not go.
Yes.
Yeah, and then yeah, every other one I've written so much threads on Twitter where I highlighted different links to get different data from. So I think I could actually highlight it again. So you can just check it there. That's my Twitter and thank you.
Yeah, thank you so much, Feromi. It was really an awesome question. So if you have any question regarding, sorry, we will not be able to take question because of time. If you have any question for Feromi, you can reach out to him on Twitter, Feromi_Babs, and he'll be able to attend to all your questions. And let's enjoy the rest of our day. Bye for now. And let's also join the next session. Let's use the calendar link and join the next session, the event link. And I think the next session start by 11:20. Please let us enjoy the rest of our day. Bye for now. Thank you and have a wonderful day. Thank you so much, Feromi. Cheers,
Yeah,
everyone.
thank
All
you.
right, guys. Bye.